Hey guys, it's Adam B. the Science Tutor, and welcome back. Today we're going to be talking about cyclohexane chairs and chair flips, and what the equatorial is, what axial is, what each stand for, and what they mean. So it's kind of exciting, but today we're going to look at it and we're going to see equatorial equals, let's be doing another color so you guys can recognize, it's more stable. And then axials are less stable. But let's not get too far ahead of ourselves. Let's look at how to draw the cyclohexane chair anyway. So a cyclohexane chair, to start off, they can be a little tricky to draw at first, but after getting some practice with it, you'll be able to draw it really well. So first thing you're going to do is make two parallel lines. And what I try to do is I try to even the lines up. So this is what I do. I mean, you don't have to do this once you're good at it, but you kind of want them to have even parallel lines, and then the one that's going higher, you're going to do a down shooted line, and the one that's going to the bottom, you're going to do an up shooted line, like that, and then you just connect your dots. And that is a cyclohexane chair. So another way to look at it is this is the front of the chair where you may lay back. So if you want to draw a little person here, they're laying back and they're sitting right here with their legs. See that? So the person sitting on the cyclohexane chair, it's kind of standard. That's another way to look at it. So you might want to draw your person like that. But the cyclohexane chair is a cyclohexane. Too many. To an octane. Alright, cyclohexane, but this is a cyclohexane. Okay, so these are equal to one another, and what you're going to look for is, it's sometimes in a question or on test, it's going to tell you to write the cyclohexane, or write the chair. So this is what the chair is, and each of these is a carbon. So you have one carbon here. Let's do some so you guys can see it better. So it's red. So you have one carbon here. You have one carbon here. This is an ugly cyclohexane, but it's okay. We'll get on with it. So there's two. This would be your two. This would be your 3, 4, 5, 6, 4, 5, 6. So as you can see, they both have 6 carbons. They're both cyclohexanes. This is just in a chair configuration, and looks to see where the molecules are placed and how they are placed. And what you're going to get into is what's more stable and what's less stable. So as we know, a cyclohexane, it has 2 hydrogens attached. Hydrogen, 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 because carbons all make 4 bonds, like we talked about before in my last video. Hydrogen, hydrogen. So there's hydrogens attached, but as we know, they don't have to be shown because hydrogens are implied. So in organic chemistry, as we talked about, it's implied that carbon has 4 bonds unless specified with a negative or positive charge. It has all the hydrogens, it has 4 bonds, 2 hydrogens attached if it has two bonds. So the same here. So what you're going to see is equatorial and axial, and these are where the hydrogen is placed on the molecule. So you're going to have an axial hydrogen and equatorial. So I'm gonna get to this right now. So when this is a good way to memorize it. So if both lines are going forward or up, then the axial will be up, and the equatorial, you'll take the opposite side, and it'll be almost like a mirror image to it. So this is a mirror image. The equatorial is a mirror image to it, the hydrogen, and the axial is facing forward. So if this one's facing forward, which way would this one be for the axial? Both of them are going downwards, so the axial will be down, and then mirror image, 2 hydrogens. This one, both of them are going up, so erase that now. So we're going to have 1 hydrogen here, and get this one. This is going to be a little tricky, but we're going to put a hydrogen right here. right here, we're going to go, it's going to be down, and we're going to put one up. Right here, we're going to go, they're both going up, so this is, the axial will be, hydrogen will be up, this will be mirrored. So right here, we're going to go down, and then this will be also mirrored. So, as you can see, these both are the same molecule, they both have all hydrogens, and if you can recognize it, or if you have recognized it, there's a certain pattern that goes on. So, you have a axial going down, and then you have an axial going up. And then you have an axial going down, and then you have an axial going up. So, okay, so Adam, so what does it matter if they're all hydrogens? Well, it won't matter if they're all hydrogens because they're all stable and it's 50-50. So like some 50% of them are facing up, 50% of them are facing down. So what of it? But this is all for the stability, and we're going to see more with methyl groups and pretty much for methyl groups and other attachments or substituents that are added on here. So let's per se, we're going to use this model again. Let's just say on this carbon right here, we're going to also have a methyl group. And then for this carbon right here, we're going to have, let's do, for this carbon, scratch that. For this carbon right here, we'll also have a methyl group. So AMAT, it's a smaller way of putting CH3, you can put anything, it's just a methyl group. So we have a carbon here on the 1 carbon, and we have another carbon here on the 3 carbon. So when you look over on your cyclohexane chair, when looking at it, you can start from anywhere as long as the placements are correct. So if it's a 1-3, you need to number your carbons off, make sure it's a 1-3, and stay consistent. So this is 1, is your 1 carbon, this is your 3 carbon, that means this is your 5th carbon. So the same way over here. So let's start here, and let's say this is our 1 carbon, and let's say this one is our 3 carbon. So let's scroll. Our 1 carbon, so our 2 carbon, 3 carbon, same, these are 1, 2, 3 carbon. So a methyl group is over here, so let's put our methyl right here. And our methyl group is right here. So, as you can see, the methyl group is both on the axial. So they're both not very stable. So if on a test they ask you draw the most stable chair conformation, this will not be the one you want to draw because it is not the most stable conformation. Because you could do a chair flip, which I'll show you in a bit, and we're going to discuss that. It's a little complicated, but you're going to get it right now. So this equals this. So we did that correctly. Now let me show you what a chair flip is and how we dissect that and how we make that. So I drew this one really big, but let's see. Let's do the black marker. Okay, so to do a chair flip, you're doing just that. You're flipping the entire chair. So you're going to do the same way. We're going to draw both our parallel lines, and then you're going to go downward, and then you're going to go upward. So you can connect the dots the way I showed you before, but if you're quicker, get better at it, you can do it quicker. So we did a chair flip. So this one is now our 1 carbon. This one right here is now our 2 carbon, and this one right here is our 3 carbon. Hope you guys see that quite well. And so what you're going to do is you're going to put your equatorial and axial molecules on it. So we have one axial, we have one equatorial. Sorry. Oh, these markers are bad. So you have one axial and one equatorial. One axial, one equatorial, one axial, one equatorial, one equatorial, one axial, one axial, one equatorial, and then one axial, one equatorial. So let's fill it up and see what we can find. So we have, this is our 1, 2, and 3 carbons. We know that the rest of them have hydrogens, so let's just place them on there just to show you. With hydrogens, hydrogens, hydrogens. And let's start with our 1 carbon and see where they last. So there's a little phrase, and courtesy of Dr. Davis from Howard University, is what's up stays up, what's down stays down. So when we look at our one carbon, where does the methyl group go? It's up, because it's an axial. It's up, facing upward. So it's upward. Our two carbon, we have two hydrogen groups, so it's not going to matter. So we could actually fill out the hydrogens on the two carbon already. So there's hydrogen, hydrogen. And then a three carbon, what's up? The methyl group is up. So we know that the methyl group is going to face up. So let's look over here. So one, which one's facing up? This is an equatorial group, and this is an axial group. So the axial group is facing down now. So that means that's where a hydrogen is going to go. Even though it's equatorial, it's now an axial, and then it flips. So now the methyl group is equatorial, which is more stable. Same way over here. What's facing down, hydrogen, so that's on the axial now. And the methyl group is on the equatorial. So there will be an equatorial right there. So that chair flip is the more stable of the two options because the heavier or the bigger methyl groups are obviously bigger than the hydrogen groups. So it's going to be heavier, and you don't want them to collide with other molecules. So that's the importance of this. So when things are equatorial, they don't collide as often than axial. Axial, everything's up, and they can hit each other. They can turn into one another. So you don't want your big substituents on axial. For more stable compounds, you want your big substituents on the equatorial mark. So you could do this by doing the chair flip. So we're going to look at this again. I hope you guys recognize it, but we're going to see how it can be also done and just a simple way of how to flip it. So, and I know it's a lot of information for right now, but you just have to get used to it. So let's say we have our cyclohexane, and then let's do the methyl group, and let's put another methyl group. Okay, so here we have a cyclohexane, and in the test they're going to ask you, okay, change this into a chair formation. So you're going to go ahead and do it. You're going to draw your two lines. Hopefully they're a little bit prettier than mine. So, okay, so then you're going to go up, and then down, down. So here's your cyclohexane. You're also going to have to draw the flip of it because it's the same molecule, but it's in a different formation due to turning during the turn. So you're going to figure out which one's more stable. So it's also that's really ugly. Okay, so you're gonna have one like that and one like this. So it's could be either this one or this one, and I'm gonna ask you guys which one's more stable. So we're gonna fill this up. I'm gonna put this as my one carbon, my three carbon, or to my two carbon. I'll put this one as my 1, 2. So if this one's my 1, this one has to stay 1. You have to be consistent, so the flip has to make sense. So this is flipped, so this one's my 1. Where would this one be? It wouldn't be up here, it'd be here. On it. So this was the start of cyclohexane chair formations. So hopefully you guys come back and watch part 2, and that's where we're going to get into new concepts of wedges and dashes, which is important to the overall lesson plan. And yeah, hopefully you guys take notes. Look at the worksheet in the bottom. There'll be some practice problems. And yeah, subscribe. Please like and share with some friends and family. Appreciate it. And I guess see you guys next time.